Okay, let's see. I'm trying to make a video for questions 6 through 9, 6 through 8, 6, 7, and 8. Okay, so these over here, what was this, 3 through 5? These had a graph, okay? So I'm sure for most of you guys, the ones with the graph might have been a little bit easier because you can visualize it. They're not giving you any graph down here, okay? When you see it on the test, it's going to look like just like that right there with no graph. I recommend, if I was you, I think the smartest thing to do would be to draw a little graph like that. Give yourself some axes and plot a couple points. It's going to help you understand what's going on here. So just draw your x and your y axis. Now, every one of these word problems, we're going to have to find the zeros, the x's that make y equal to 0. I'll tell you what I'll do. I'll do 6 and 7 on this video. And I'll do a separate one for 8 because that's a little more work. All right. So, the number of mosquitoes in Brooklyn and millions of mosquitoes as a function of rainfall in centimeters is modeled by. Now, we had a whole test this semester on function notation. So function notation, they're telling me that the number of mosquitoes in Brooklyn as a function of rainfall. So this function is giving us the number of mosquitoes, and that is as a function of rainfall. So as a function of, that's the x value. The rain is on our horizontal axis. How much rain is coming is the horizontal axis. And m of x, when you plug in how much rain we get, m of x tells me how many mosquitoes there are. So mosquitoes goes up and down. Rainfall goes left and right. Let's plot these 2 points that make this equal to 0. So we're figuring out what makes y 0. Okay, if I can figure out what makes this 0, I'll know where my 2 horizontal intercepts are, and that's going to help me see what's going on here. Now that x that's highlighted in pink, a lot of people struggle when they see an x that's not in a factor, but that's actually the easiest one of all. That, if we make x equals 0 right there, 0 times anything equals 0. That's all you got to do is plug in 0 for x. I'm going to put that on my graph over here, right here at the origin. When x is 0, y is 0. Now, how about this one that's highlighted in orange? X minus 4. I'm trying to think, what is going to give me a 0 in there? What could I make x? Some number minus 4 that equals 0. And that's basically just the opposite of negative 4. It's positive 4. 4 minus 4 is 0. Okay, so that's going to make y 0. Because anything times 0, 0 is our 0 product property. I'm going to need my orange marker. I'm going to say 4 is maybe like somewhere over here. And now I'm going to go back and reread this question again. Down here it says, what amount of rainfall results in the maximum number of mosquitoes? So where is the maximum? We've got this graph. It's a parabola. It goes through these 2 points where y equals 0. And when we're looking for a maximum or a minimum, on this test, I stuck with all maximums for you guys. When we're looking for the maximum, we're trying to figure out what's exactly in the middle of those 2. It's always going to be right in the middle. So we're thinking 0, 4 is 4 away from 0. Half of that would be 2. Something that's 2 away from 0 and 2 away from 4 happens to be 2. 2 is right in the middle. So we'll plug that right here. And then if I were to graph this thing, here's my mosquitoes. With 0 amount of rain, we had 0 mosquitoes. They kept growing until they hit 2. And it started going back down, and we had 0 mosquitoes at 4. So up here is your maximum, your vertex. That's where the max is at. Now we got to be careful. On this question, it said, what is the amount of rainfall that results in the maximum? Well, that's going to be 2. 2 is our answer, okay? But if they said how many mosquitoes were there, what was the maximum number of mosquitoes, you'd want to plug 2 in for your x's. And then you get 2 minus 4 is negative 2. and then you multiply that times -2, you get, it looks like there'd be like 4 million mosquitoes at the max. But they didn't ask us to plug it in. They didn't say how many mosquitoes were there. They said how much rainfall needs to rain before we hit our maximum as to that X value of our vertex. Here we go. One more of these for this little short video. There's a hovercraft. It takes off from a platform. Its height in meters, X seconds after takeoff is modeled by. So its height in meters, X seconds. See where it says X seconds? That tells me the seconds are on the horizontal axis. Here's my time. Time is almost always on the horizontal axis. If it's weeks, months, seconds, days, years, time, when you're dealing with functions, is pretty much almost, there might be a few exceptions, but it's almost always horizontal when you're dealing with time. Okay, let's get our zeros. They didn't give you the graph. Once again, I'm telling you, there's no graph. It's just a bunch of words. Draw a little axis for yourself. I think it'll help you a whole lot. So let's get this orange X over here. The X is highlighted in orange. I'm thinking, what number minus 11 equals 0? And that's 11. 11 minus 11 is 0. So over here, I'll plot on this point. After 11 seconds, this hovercraft was basically on the water. It had a height of 0. And the pink X is -3. We could plot that over here. I don't think we don't really need this part on this particular question. But if we were to graph this thing, check it out, my hovercraft. It doesn't take off till 0, okay? Really, the -3 doesn't really apply to anything in this other than when you're trying to figure out the vertex. If they said, what's your maximum, I'd plot my -3 and my 11, and I'd figure out what's in the middle. And then if they said how much was the maximum, I'd plug that number in the middle back in to find y. But they didn't. They just said, when does this hit the ground? Okay. So we don't really care about this -3. I'm telling you, when you're dealing with time, don't look back. We always look forward, okay? This works in life, too. Don't worry about what happened in the past. You got to focus on what's ahead of you. So really, as far as this hovercraft goes, nothing really happened until 0 seconds. So all we care about is from 0 until it touched the ground again at 11. So we're going to pick 11. That is when this thing hit the ground. And why is it not -3? Because -3 doesn't really make sense when we're talking about the flight of this hovercraft. All we cared about is when it took off at 0 seconds on that vertical axis.